It's great to be with you again. I think I'm a little soft, so let me try to turn myself up slightly. Check 1, 2, check. Is that better?
Yeah.
Sounds a lot better, I think. Okay. Let me get my presentation up.
Here you go.
So yesterday morning, we talked a bit about how to build a frame and what we would be building. I'm going to try to balance this, excuse me, sorry. Okay, is that? Okay, okay. So we actually talked about what type of materials we would use, a mild steel versus a chromoly versus aluminum versus titanium. And we basically stopped off and said, here's your basic frame. Well, what do you need to put on that frame? You have to start putting on your wheels, your brakes, and suspension. That's what we're going to talk about this morning. After that, we'll talk about the electrical portions, powering up your solar car, power management, and then aerodynamics. Okay, so wheels. There are so many different choices you can make with wheels. And so we'll walk you through basically what you need to do. The key thing about this, as you plan out, back to my project management stuff, is you have to make this decision fairly early, because this is, your frame is built around where your wheels are. You have to find some way of capturing those wheels. So you're going to need to make that decision fairly early. Okay, so the very first trade you're going to have to make is 3 wheels or 4 wheels. Okay, in a 4-wheel design, you're talking about a standard, car design. You have 2 front wheels, typically 2 rear wheels right, immediately in line behind the front wheels. And there are benefits to that. When you're used to driving cars, or for students who recently got a driver's license, you start practicing, you learn the car. When you hit an object in the road, or if you have a pothole, what do? You straddle that pothole right in the middle of your car, and so that between the tires, and you won't hit it. So that's a good thing compared to a 3-wheel design. Of course, with a 4-wheel design, you have an additional wheel. That means that you have additional point on the ground, which increases your friction that you have. You have to make sure that all the wheels are properly aligned. It's not just, if you have a 3-wheel design, you typically have steering in the front, your drive in the back. You just align the front wheels, you're good to go. On the rear, you're going to have to align all 4 wheels together, and especially if they happen not to be aligned together, you have a bit of work ahead of you. Weight distribution is less critical, and let's talk about that a little bit. So in a 4-wheel design, you have 4 patches of area that you're going to distribute your weight across. Which means, as long as you get components between your front and rear wheels, you're pretty much good to go. In a 3-wheel design, you start having to look at loads, right? If I were to put a whole bunch of weight up front, then you can split that weight out between your front wheels, and you have equal load across that. If you shove a whole bunch of stuff in the back, now you've got a single wheel carrying a whole bunch of weight, and you have to say, is my wheel selection supporting the weight that I have to hold? Typically in a 3-wheel design, you're going to have a bigger, more substantial wheel and tires in the back, because you're going to have to support more weight. You don't have to do that on a 4-wheel design. You've got, of course, redundancy in a 4-wheel design. So if you have a flat, you've got 3, you've still got a tripod. And we already talked about straddling, in this case, dead animals on the road, which we have seen, by the way. Now, some of the wheel choices that you may make. For a long while, a lot of teams liked using what's called the new generation motors, wheels, and tires. They are essentially really lightweight alloy wheel. It's actually shown here. That's an NGM wheel and hub. And they've got some really thin, high pressure tires called the Bridgestone Copia tires that you put on top of them. They could run, I think, on the order of what, 120 PSI or something like that. Very high PSI, that means very low friction for you, right? I don't know if you're going to be able to procure something like that nowadays. You might be able to find some old solar car teams that have it. NGM's not really in business anymore, so they're not going to sell it to you. If you could get your hands on it, that's a consideration. A lot of other people use, if you want reliability, so let me take it aside for a sec. In my first year of cars that I build, I always say I'm going to build something that works. I'm going to overbuild a car, put it there so that I can just run all day. If I can do that, I will probably be in the top half of my division, just because I have no breakdowns, okay? So I overbuild, and so one of the ways you can overbuild and be sure that you're not going to have any issues, put a motorcycle wheel and tire on there. And the motorcycle wheel and tire is meant to carry a lot more weight than you would have on a solar car anyway. You're likely not going to get a flat unless you actually run something over, right? If you want to optimize a little bit, a lot of teams and a lot of solar car teams have actually started moving into what we call a moped wheel and tire. It's a little bit smaller than a motorcycle wheel and tire, but it still has a substantial material that can carry weight. And then finally, there is an option to put bicycle wheels on there. That decision is a very difficult one to make because bicycles are not designed to carry the loads that you would have on a solar car. In a bicycle, the wheels and tires are really intended to be rotating on the axis, right? If you're riding a bike, if you're turning, you tend to lean, and so the loads stay in line with the bicycle. In a solar car, as you put multiple wheels on there, your forces tend to be, you don't lean your car over, right? So you have some lateral forces on that bicycle wheel, and and they're not really designed to do that. So it's possible to use bicycle tires and wheels if you have a sufficiently lightweight vehicle that your loads are not close to what the bicycle is. But it's really, you really have to think hard about whether or not you want to do that. I know Chris has something to bring up, I can tell.
Do you have a microphone?
Yes.
Thank you.
So I have to say, for first-year teams, I do not at all recommend bicycle tires. I also would not recommend spoked tires. Often I'll see teams take things off of motorcycles, and occasionally, like for their rear drive wheel, they'll use a motorcycle tire that's spoked. That's a little bit different. That's heavy duty. It's made to carry the weight of a motorcycle. Will work fine with a mild steel car. I would suggest once you have a platform, once you have your first car, get something, again, we've said this time and time again, that's reliable first. Go back second year, or go back for the second competition you're going to attend and try and lighten it up, try and trade things out. But when you're talking bicycle components, unless you have a car that is ultralight and only is going to weigh a couple 100 pounds, those components are going to set you up for a possible failure or issues during the braking test, because if you use bicycle wheels, you tend to use mountain bike disc brakes, which again, they're made to stop a person riding on an ultralight bike, not a 800-pound steel car with driver and batteries. So just be cautious about that. Personal experiences, I haven't had good luck with spoked wheels either, except again for something you pull off like a motorcycle or get in a junkyard, that's probably okay. It's meant to carry a couple 100 pounds. So just wanted to add that. I know William's trying to present all the options to you guys, and if you guys want to try and optimize later on down the road, great, but go for reliability first, especially because, again, personal experiences, we've had wheels fail when we were trying to use a spoked wheel on the road and cause...
Why does it fail?
Huh?
Why does it fail?
Because spokes, when you get thin wire spokes, they're not designed to take the kind of load and pounding that you put on it with a solar car. You're meant to have give some shocks that take it, because when you put high force, high impact on spokes, they bend. As soon as spokes bend, they don't do their job anymore. When you get one spoke that fails, you're still okay, but when you get multiple spokes that fail, because you have a mechanism set up for it, you've then compromised the integrity of the wheel.
Spokes get loose, puncture the tire, wheels goes down, and you go into a ditch.
You go into a ditch, or worse, which happened to us when we were out in the desert, the car can go into the other lane of traffic. Luckily, no one was in that lane at the time, but it's one of the most frightening things we've done. So I can't stress enough, this is a part, if you're going to overbuild your car, overbuild the wheels and the suspension and the brakes so you have confidence in it. When you go on a road, when you go on a rough road, I mean this cross-country event, don't skimp out there, especially if you haven't had a lot of time to do testing. Again, second event, go back and optimize. But first, build confidence in it and be safe.
I'm just, here. Oh, question. Here.
So is it actually the wheel that's failing, or is it the rubber? Because actually, in my experience, it's always been the rubber because of the thinner, smaller.
We have seen wheels fail. We have seen the spokes bend and twist as was shared, and so yeah, and you're going to have flat tires that just puncture, but we're not talking about that type of failure. We're talking about the load of a solar car actually causing the wheel to fail.
Spokes fail, then the wheel punches and snowing around.
It's not because the heat builds up or anything like that.
No, it's
No.
literally because you're putting too much weight on something that wasn't designed for it. And again, like,
And it's the forces that's the problem. The force is not. If you had all the forces straight up and down on the wheel, the bicycle tire, the wheel is meant to carry the force in that direction. It's when you go laterally, it causes a twist in that type of wheel that can cause it to fail.
William's exactly right. Whenever you're on a bike, gravity is always pushing through the wheel, through the spokes, through the tires. It's always straight. But when you lock them into a solar car, into a four-wheel configuration, you talk about, sometimes your suspension tips a little bit, so now force is being put down on an angle, or it's twisting, it's trying to twist the wheel as you turn. That kind of stuff, spokes do not handle that well at all. So something that's heavier. And when I say spokes, I mean the thin wire spokes when you get, 20, 30 of them in a wheel kind of thing. I don't mean like something that's billet aluminum, like even if they had shaved out the adjoining metal and you were left with just the big 5 spoke pieces. That's different. I'm talking about the wire spoke wheels. I would strongly avoid those.
Yes.
The MGM wheels, let's say, I think I can talk about it. Let's say you find one on eBay. Can you find tires for that thing or no? Is it hard to find tires for the MGM now?
In the same way that you'll be able to find the MGM wheels, you will likely be able to find teams with the Bridgestone Ecopia tires that fit that wheel. They're about the same availability, which is difficult.
Usually they're using moped tires on them. They put
But moped tires,
Yeah.
These wheels, I've seen them for about $600 now for a used wheel beat up. They just don't exist anymore.
Okay.
And of course, there are wheels that look just like that, made out of carbon fiber, that are ridiculously expensive, thousands of dollars. But Brent's not here, is it Brent Gregory?
No.
They have the new Mitsubishi motor, and the new Mitsubishi motor comes with a wheel just like that, same specs. And I don't know how much they charge, but he's got 4 of them in his car, so I know you can buy extra ones. So they exist. What Mitsubishi sells them for, I don't know.
What was the name of the group, Newman?
Liberty Christian?
Yeah, Liberty Christian has when we get the hub motors, we talk about the Mitsuba hub motor.
Okay. And the last thing on that NGM, is it a chain? Are they using a belt drive or a chain on that? It looks like a belt.
No, actually, when we get to the motor section, we'll talk about this is an in-hub motor.
Okay.
It's just it's mounted straight onto the wheel and it drives it directly.
Okay.
Thank you, Brian.
Any other, did you have any other comments?
I'll get to that when we get to the hub motor.
Okay. Okay, so that's the wheels discussion. Some other, possible. We're talking about motorcycle wheel on the left, bicycle wheel on the right.
Like
There's the spoke thing that Chris is talking about.
the wheel on the left would scare me.
So, some sources for you. We didn't get into a discussion, and I probably know why. The three-wheel design discussion. Mark Westlake, who usually presents this, is a fan of the four-wheel design, primarily if you can see all the advantages that are on the screen. I have never built a four-wheel design, and I'm not saying that the Solar Car Challenge endorses any particular design. I just want to make that clear. I just haven't built a four-wheel design. All our designs have been a three-wheel design. That's two in the front, one in the back. The two in the front is meant to steer. The one in the back is meant for driving. And the reason why we do that is we simplify the steering geometry that way. For us, the way we do steering, even though steering suspension, there are programs out there to optimize your toe, camber, all the things you can change out of there. The way we do it is we draw it up on a CAD design. We draw where the center of the rear wheel is, the center of the front wheels, and we draw a turning radius, and we just connect the rear wheel and the front wheels. It essentially becomes a triangle. As long as the steering arm aims towards from the pivot of the front wheels to the center of the rear wheel, you're done. That when you turn, there will be no rubbing. It's all aligned. It's very easy to do. So that's why I like using a three-wheel design. There is redundancy issues, so you do want to make sure, especially your drive wheel, if you have a belt or chain-driven thing, you have a lot of components that are mounted on there. You really want a more substantial tire in the back, both to carry the weight, and you don't really want to be changing out that tire because it's going to take you a while to change a whole bunch of stuff out. But that's my view on the 3 and 4 wheel debate. I'm sure Chris has other comments on that.
Only one. For using a 3-wheel design, you never want to have the single wheel in the front.
Actually, our rules prohibit that
Yes.
configuration.
Just as a reminder, it's just not a good idea and prohibited.
Yeah, I will say, and I should have made this disclaimer way when I first started talking, we are trying to give you some information of best practices of what solar car teams typically do and bring to the race. There's a lot of design freedom that you have as a team to do it the way you want to and in your experience. So we are not mandating any particular design. As long as you comply with the rules, like no single wheel in the front, you can basically do whatever you want. We're just trying to give you some tips to get you started. Okay. Any other questions on wheels? Okay. Let's move on to brakes. The rules require that you have 2 independent braking systems for your vehicle. What that means in practice is that the entire chain from the actuator pedal all the way through to the calipers at the end need to be redundant. Okay? So we expect you to have 2 brake pedals. If you use hydraulics, 2 master cylinders, and then hoses to your calipers. We also require that those redundant systems are brake in a balanced way. So you couldn't get away with saying have a redundant system where you have a brake caliper on the front left as one system, a brake caliper on the front right as the other system, and expect that, well, I'm just going to press on both brakes at the same time all the time. No, that's not redundant braking system. You do need to have a matched pair for each. What teams have done, some teams have put a pair of calipers in the front and then use, let's say, either a disc or a drum brake in the rear. That's one configuration. Other teams have put a double pair of calipers up front, so you would have two calipers on the same disc on the front wheel. This is really up to you and your design freedom.
Of course, I'm going to be doing this a lot. Those of you that have been around me before know, yeah. So to reiterate, you have to have two brake pedals. There has to be redundancy in the brake pedals. I expect that everyone here will not come to scrutineering and ask me, well, we have one brake pedal, is that okay? No. The idea is we really, again, personal experiences. I will share a story with you. In 1999, I know this is before some of you were born, but I was driving our solar car. We were test driving it on the roads in Southern California because we actually had it licensed and could do that. We were moving at about 30 miles an hour on road and a light changed on me. And I went to go hit the brakes. At the time, it was just me and our advisor and doing something that, again, you should never do. We had no lead vehicle, only a chase vehicle, because it was just the two of us. And I went to go reach for the brake pedal, and there was no brake pedal. There was no brake pedal, and I was heading towards a red light at 30 miles an hour. And our car was so awesome that our secondary braking system was just a brake with a lot of air in the line on the back tire that did nothing. So I was in a very, very panicked situation when I did that. Ended up trying to swing a wide right turn and kind of drifted out into the opposing lane traffic. Luckily, was not hit by somebody and just tried to bleed off speed. The reason for it was I didn't put a lock nut on the bolt that held the pedal there. I did it to myself. I didn't Loctite it, no lock nut, and there was only one pedal. That is the genesis for this rule of you now have to have redundant braking systems. So if any one part fails, you still have a way to stop, because we don't want you to be in a dangerous situation like I was where you don't have brakes. Most of our rules, I know sometimes they seem overbearing and ridiculous, but they have usually been spawned by one team or another, and I would say 2/3 of them was my team. Yes, question?
So would it be okay if we had one brake pedal and then like an emergency brake lever?
Levers are not allowed for the brakes. Again, learning experience from our car, we had the secondary brake was actually a lever that you, again, steering wheel was behind your head, brake lever was behind your head. You pulled on it, nothing happened. So we also encourage through the rules that the cars be in a normal driving configuration, especially for newer drivers, where both hands can be left on the steering wheel and your feet are free to operate the pedals. The concern is, and again, personal experience, I have literally spun out a car during scrutineering in the braking test because our brakes were not that stable. I covered it up by telling the judge I did that intentionally, that I was showing off, figuring that that was better than them questioning that I couldn't actually stop the car in a straight line. So what that did is cause us to say that, okay, sometimes solar cars, let's be honest, we all know we get a little air in the lines with brakes. You guys will experience this if you haven't. They don't always stop the easiest. You have to give it a little bit of steering wheel to sometimes help it. So what we don't want you to do is take a hand off the wheel to operate a lever or something like that. So that's why the rules are written the way they are. We really do. I'm happy to talk to anyone about one of our rules, especially if you feel like it's ridiculous that we ask you to do this. Come talk to me. I'll share a story with you on why we actually have to do that now. I think that's all I have at the moment. Sorry, go ahead.
No worries. There we go. So when we talk about, that's weird. I think I'm on. You're on. Okay. I think I talk loud enough anyway. I think you can hear me. When we talk about brakes, you really have two choices of braking systems, right? You have a hydraulic braking system or a drum braking system. Most cars tend to use hydraulic disc brakes, and a very, very common brake system is the MCP brake system that's right here. Why we like that particular one is the brake calipers on those MCPs, these are essentially go-kart brakes. What's nice about them is that the calipers retract when they are disengaged. And you do have to get the right ones. You have to get the double-ended ones where you have two pistons that push in together and then they'll retract back. If you get the ones that is a single-ended and then you just have a dead end, you push in and then the dead end just stays there until motion will retract it back. You want to get the double piston version, and what happens is when you disengage, it'll take the piston slightly back, and that'll allow you to have no drag when you want to proceed again. So very common brake system, MCP. Another one place that you can get that is VMI cards.
Just to reiterate that point, we didn't know this in our team. Automotive brakes, a lot of motorcycle brakes, they stay rubbing on the rotor. You have so much power in the vehicle that it just doesn't matter. Your solar car, on the other hand, you're trying to get every little bit you can out of it. Our back brake, which was a disc brake on our car, again, way back when we was motorcycle, we used to have to go after we used it and get a spatula and pry the pistons away from the rotor so they wouldn't stay rubbing on it. So it should be known that typically, if you're trying to get as much as you can out of your brakes, be as efficient as possible, you want two live sides, you don't want a live side and a dead side, and you want to make sure that they retract. Question?
So one thing I was going to mention is on these MCP brakes you talked about earlier, they're spring-loaded, they're really great, the calipers. And if you're using it on like a motorcycle rotor, what we found is you can buy enough extra shims that those will easily just expand out wide enough and set around it. Yep. So you don't have to throw away a perfectly good rotor off a motorcycle or moped disc brake. You can just buy this equipment, set around it, and it worked great. And VMI is a great place to use.
Thank you. That's really good advice.
Yes.
Another thing we found, actually, we ended up having a problem with the calipers in July here at Texas Motor Speedway. Was what I really like about those calipers is that with an Allen wrench you can adjust those spring-loaded ends, and you know, if you have an alignment issue, slight alignment issue, it allows you to do that and just get the perfect brakes you need and still give you that spring back so that you have no rolling resistance.
Yeah, more often than not, I would imagine that 80%, I would throw out a number, of all solar car teams use the MCP brakes. You can look at the team profiles and you can see all the registrations. It's a very common part to use. Let's talk, we talked a bit about redundancy, but there, you know, if you design your brakes to be used such that your both redundant systems get engaged when you have when you want to brake, because we do require multiple pedals. This is one of the ways that some people have connected the two together. Essentially, you know, by pressing on this lever, you would also press on the next lever. I don't like this exact design because if this brake pedal was stuck somehow, I couldn't get to the other one, so I would make this slightly shorter so that I can get to the rear pedal. But this is a way that you can stay within the rules and yet still apply both braking systems at the same time.
So to add one other comment, when you do a setup like this, one of the risks that you run is if that pedal closest to William has more throw before the brakes engage than the pedal away from William, what will happen is the pedal away from William will get firm and stop, and the pedal you're pushing on to the first one, the brakes won't do anything yet because the throw is a little bit different on them. So it works both ways. If the back one gets stuck, you can't really use the front one. If the front one bottoms out and hits its stop or it's engaging that system before the second system starts really engaging, it's just not always as efficient. So just be careful about some of these overlapping pedal ideas to try and get the most out of your brakes, because I know we do have some issues, again, first year teams, with stopping during the braking test in time.
This is just a way to do it. We have seen a lot of cars that just have two separate brake pedals, and it's not too hard to, in an emergency braking, situation, since you're not going to be accelerating anyway, to just put both feet on the two pedals and push them. And then in normal operation, since they're meant to be redundant systems anyway, each independent brake system should be able to stop your car the way it is, and so you should just be able to do one of them. When we do scrutineering, we say that we test the brakes both statically and dynamically. What that means is when the vehicle is parked there, we will check each braking system to see if we could push the car forward. Okay, and that's the static test. We also have the dynamic test, which basically means that at a particular speed, you must be able to stop your car within a given amount of time. Okay, so there's a lookup table when you bring up the scrutineering sheets that are on the web page. You can stop within a particular time, and that's our criteria. Okay.
Sorry, I'm going to keep doing this to you all.
Why don't you stand up here and co-present with me?
I just want to point out to everybody, and I can come up there, that the picture right there, those are mountain bike brakes. Those are the ultralight style of brakes. You can see how tiny the rotor is. You've got a spoked wheel and the very, 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 very small caliper. That will not stop an 800-pound car. So just be aware of that. They're enticing, they're lightweight, they're thin, they're small, but they have no power to stop, and that's the most important thing. If you cannot get your car to stop in time, you will not make it into the event. So.
On scrutineering in that time window that you got to stop, if you got two pedals, let's say you have two systems, is it per system that you got? Oh, sorry. Okay.
So my question is, you have two systems that, let's say they work, and you're being tested. Can you press, let's say, both pedals down, or do you only press one down to meet that test constraint?
I have to look back. I think it's you can press both.
Yes, press both.
You can,
Yeah.
but you only have to press the primary.
You don't have to press both, but you can press both. I will lean on our braking judge over there.
It'd really be nice to have it on one. I'm just curious if you could press both at the same time.
Yeah, you're required to press the primary brake. You do not have to press both.
So to give an example of how some teams go across this when they do make it to the race, one of the ways they might do it is sort of shown up there, is you can actuate one brake pedal in addition to the other.
We talked about that.
Oh, okay.
Yeah.
And that goes to, yes, you can have two brakes, your primary and secondary system, that are actuated at the same time to stop the car during the scrutineering session.
So ideally, it'd be good to have one. But
Ideally, in the braking test, your primary brakes alone can meet the requirements, but absolutely, you can use both sets of brakes. There's nothing preventing you from doing that when you try and make the quick stop.
I will say though that, so that's the dynamic test, but statically we will test that each independent braking system will work.
That's right.
So,
Okay.
so by practice, by having both of those tests, you really need to have, be able to brake, you know, independently. So, I was gonna say, we have experience, and I will allow Chris to chime in, Chris Pearson to chime in if I have any questions. There have been recently a lot of vehicles that have had problems with the brakes, with the braking test. A lot of times it's really and the inadequacy of the brake system, meaning that let's say if you were using hydraulic brakes, typically teams don't do a good job bleeding their brakes so that there are no bubbles, so they lose the effectivity of their brakes, and so they don't stop in time. Other problems with the braking station, actually there are times in which you can't get up to the requisite speed for which we test. That's another thing to think about as we design that, and when we get to the motor section you can look at it, and we can work with you on that one. But the braking, the other thing that you have to consider is we do make sure that you are driving in a straight line when you apply the brakes. That we don't want you, when you brake, to swerve, because the idea, especially this year as you're on the road, if you apply brakes and it swerves left, you're swerving essentially onto oncoming traffic. So we're going to make sure that when you brake and at your high speed, you brake in a straight line, that you are in control of your car, is what we say. Were there any other thoughts on braking?
Nope, you covered it.
Okay. So, yes, question?
Is there a limit on how much rubber hose you can use total?
No.
And okay.
However much you need to use.
Okay.
You got it.
Yeah. Okay.
I have a question.
Yes.
Hey, so what are the rules on regenerative braking, like using the motor? Can you use that during your test, and can that be your secondary braking system?
The answer is you can use regenerative braking in your car. It cannot be one of the two redundant braking systems.
Okay.
So you're legally allowed to use regenerative braking, and especially on the road, you know, as you go down hills and things like that, you can use regenerative braking, but it won't count for your braking test, and we will not allow you to engage it for your braking test. Okay.
Regen is great. Like, highly recommend it if you've got a controller and a motor that supports it. It's just not a braking system.
Okay, so let's move on to suspension. Okay, so being a road race, suspension is important because you're going to have all sorts of things on the road. Even though it says it's more important on the road than on the track, it's important on the track too, because for those teams that I was talking to one earlier today, if you're targeting the next track race, we want you to know that while on the front and rear straightaways, you will be on the track proper. On the turns, because of the banking, you will not be allowed to run on the banked portion of the curve, which basically means that on the turns, you're driving down in the apron, the shoulder of the track. And there's a lot of debris on the shoulder of the track. So let's say this, I had designed a car for the track that had no suspension or had some very rudimentary suspension. It was not a pleasant drive. I mean, if you want to do that to your drivers and keep them awake, perhaps you're free to do that, but you do want to consider suspension. Of course, you know, as with any additional parts, it will add weight and complexity to your design. But you know, if you have a lot of things shaking around in the car, especially the way we wire our cars, things are going to get disconnected, things are going to, you know, just the flex on wires, there would be all sorts of problems. So you really want to consider doing that. So we go, okay, so what types of suspension systems? You know, this is a fairly standard AA arm suspension with a steering connection. That's one possibility. I think this is another type. As you can see in this particular picture, it's essentially fabricated. Someone went and fabricated that design, you know. Whereas in this one, these are essentially, you know, bought components. You can go either way. I think there was something, some place, I think it was called Chassis Shop or something like that, that have different parts. We've had some successes. I think on the Walnut Solar Car team, we bought some Willwood AA arm things. There are parts out there. And if you look at your list of sources that we talked about, and that's uploaded on the website, there are places that you can buy these things. Some teams have actually taken, let's say, a golf cart or some other type of you know, pre-made front end. I think, you know, we're talking. Joe was talking about how they had an entire front end. That is a way to do it as well. It's just, you know, how comfortable you are at doing that. Anyone else have words on suspension?
The biggest force on the wheel is the braking, so
yeah,
that's what we have to watch for.
And regarding suspension during the race, when you get to scrutineering, you also want to be sure that your suspension, and we've had this happen in past years, that the suspension is supporting the car relative to the weight of the car. So you may have a very heavy car with a very soft suspension that affects your ability to control the vehicle. So ensuring that when you're designing and picking out your suspension and everything, that it's being conscientious of how you're intending to use it when you do get on the road race, so you do maintain control of the vehicle. Of course, when you go to the race, one of the scrutineering stations, which we'll cover later on, involves looking at this and examining to see if you're able to control your vehicle, and sometimes the suspension can get in the way of that. So being conscientious of that.
Question?
The gentleman up there said something, I'm not sure what he said, I couldn't hear it.
Oh, you're talking about the force on the brakes.
Yeah, the greatest force you're going to have on your front wheels is the brake force. Nothing else compares to that. So that's what you're going to be testing for.
Is that our only?
Personal experience again. We built all the mounts for our calipers out of aluminum in our '98 car. We built the axle that was going to carry everything, the spindle, everything was aluminum. We decided about 2 weeks before we got to the race, again we were driving on the roads in Southern California, that, you know, we ought to go on a little residential street, try the panic stop. So I panic stopped the car, and every aluminum component sheared, and our car just kind of face planted on the ground. So Lee is right. The most stress they're going to see is when you engage the brakes. So you want to make sure that the components that you use to hold your calipers, rotors, axles, spindles, all that stuff is tough.
Shannon, go ahead.
I want to add to the fact on the
shocks. If you've got an overhead panel design like what we had on our car, what we made the mistake of last year is not having adequate damping. Adequate damping and stiff enough springs. We had too soft of both. And so as we would go to do our slalom or turn, we had too much shifting of the car. So if you've got an overhead panel design, be sure to get sufficient stiffness of springs and damping so that you don't have as much problem with that, or add a sway bar in. We've got to do one or the other of those and just learn from our mistake. Don't do that yourself.
Yeah, another thing you have to consider is that it's the sizing of the shock, right? I mean, yeah, the geometry of the A-arms matter, and that's the toe and camber adjustment. You can, there are online resources to figure that out. I think the key thing that Shannon's referring to is the shock load. You need to be able to consider how much force that's going to take, and can it support, especially not only an issue with you're having overhead arrays, but it's really the weight of the car, and can the shocks really dampen that, or is it going to be, let's say your car is 800 pounds and you've got shocks that support 250 pounds each. Well, you're going to get shocks that ride very soft, and that is really on the low end of the travel. So when you start putting all these things together, they're all interrelated, and you have to consider it as a whole. Question?
I think you answered it.
Okay.
So if you have a 900-pound car,
Hello?
if you have a 900-pound car, pretty much you're going to want 300 pounds on each wheel, maybe a little bit more on the front. So you can weigh your car with bathroom scales. You can use a bathroom scale to weigh one tire individually, then add up the other three, and you can find out what the car weighs and split them up, and that'll give you an idea of how much spring you need.
Yep. Okay, so alignment. Alignment is key in this race because anytime you're not aligned, you're basically wasting energy. Your tires are rubbing, and you're just not gonna get the most, the least rolling resistance. And maybe I will ask Michael to share his experience on the Winston team with regard to alignment.
Howdy guys, Michael Fourier again, Technology Director. So my days back on the Winston team, we had a four-wheel design, we had Ecopia tires. They look like overbuilt bicycle tires, very smooth, lightweight, and great rolling resistance. The issue that we had with our wheels were they towed in or towed out anytime we hit a bump. They would shift back and forth, and when that happens, you are rubbing rubber on the road behind you because they're not rolling perfectly with the direction of the vehicle. We went to Australia, and within 7 minutes we were on the side of the road changing a flat tire because our wheels were towed in. So we changed the tires, we changed the camber so that they weren't towed in or towed out. And then we got back on the road, and about 10 minutes later we were on the side of the road, again, changing the tire. I think in the first day we changed maybe a dozen tires because we couldn't get our tires aligned properly. There's a lot of fancy systems out there that help you align, and we had at least one of those fancy systems that used lasers and measuring wood and things like that, and it worked okay, but our favorite method of alignment was to get two really long 2x4s and then put them up against the wheels and then measure the distance at the top of the 2x4s and at the back of the 2x4s and make sure that they were the exact same distance apart from each other. Let me come to you with a mic for the question.
So when you guys are talking about towing in and cambering issues, what kind of a travel did you have on your suspension, on your A-arms?
For that particular vehicle, we changed the suspension so that we had the minimum travel possible. I'm going to guess it went up and down maybe an inch.
Yeah, it is something to consider when you think about the alignment, is that the suspension design and the way it angles out is part of that consideration. To me, that's just going to be the nature of your car. There's going to be nothing you can really do to align. I mean, basically, it's just you do what you can to minimize that in your suspension design, so that when you get to alignment, you just align your wheels that way. I think one of the things in terms of alignment is we were actually taught, I think it was Byron Nelson who had come up with that. They essentially had this two metal plates, sheet metal that just put right next to the wheels, and then you just measure also on the top and bottom across and make sure that things, when your car is going straight, the distances in between are the same. So that's definitely something to consider as well. Adding when we're talking about design here, that these are things of alignment you have to do every day, great. But in terms of design, if there are things you can do to add adjustability, it's worth the effort. So most of the time, you already have that. In terms of your steering, you're going to use some rod ends that have some type of bolt you can turn, and so you can adjust your alignment as you go along. Rear wheels, if you typically have a slot, not for alignment purposes, but you can adjust the travel on your chain or on your belts. That type of adjustment is good to have. Some links for resources there. Okay, so that basically concludes the mechanical side of things. Given time, do we want to take a 5-minute break? Stand up.
Yeah. We need to break that in here.
So we'll take a quick break, and then we'll get to talk about the electrical side of things.
Talked about brakes.